Okay, so from 5 to 10 a.m., the rate at which vehicles arrive at a certain toll plaza is given by A and T, where T is the number of hours, A and T is measured in vehicles per hour. Traffic is flowing smoothly at 5 a.m. with no vehicles waiting in line. Right, but do not evaluate interval impression. That gives the total number of vehicles that arrive at the toll plaza between 6 and 10 a.m. So it should just be an easy setup there, part A. So in class, we're going to try to work through 2 FRQs. So page 9 and page 14. We're going to take out the 2022 FRQs. Which page is it? We'll get my copy. Go ahead. Yeah, I'll come around actually. I'll come around and I'll check you guys off while you guys are working on these problems. That way you can just. But yeah. Yeah. It's just that. Yeah. That's fine. Okay. No, you're good. Okay, very good. Part B, average value theorem. So if we can recognize that formula, then 1/5 minus 1, integral from 1 to 5, absolute integral of a of t dt. Practice entering that in your calculator. Part C, is the rate increasing or decreasing? So that's talking about something in that second derivative range, right? We see the word rate, we see increase or decrease. We know that A of t is already a rate, so we're asking about whether the rate is increasing, so we're going to find the derivative. So we're going to find A prime of 1. We know this is going to be vehicles per hour squared. That's a positive A prime, so since A prime is greater than 1, it's greater than 0. Sorry, the rate that vehicles arrive is increasing at t equals 1. Yeah, anytime we see the word, words rate is increasing or rate is decreasing, we know it's talking about some second derivative calculation there. So A through C, I think is pretty straightforward. Part D is where we have to go through a few more steps there. We know it's extreme value theorem for part D because it says find the greatest number of vehicles. So anytime you see the word greatest or least, it's essentially trying to get you to apply extreme value theorem and find your absolute max and absolute min. So for extreme value theorem, we're going to test endpoints and critical points. So critical points is where we have our function in question, the derivative equal to 0. So if you look at n of t is defined as the integral of a of x minus 400. So if I want to find n prime, if I want to set n prime equal to 0, I know second theorem will allow me to take away that integral. I'm just now sitting at the a of x or a of t minus 400. And that's my n prime. I set n prime equal to 0. And the strategy there is you graph the derivative, and then you look for the x-intercept. So a of t minus 400. You may have to adjust your windows so that you can actually see a curve hitting your x-intercepts, and they should come in at 1.469 and 3.598. So now you're going to be testing your critical points and endpoints. So you have 2 critical points, and then your endpoints are at A and 4, and your A is your 1.469 because that's your critical point. That's your x-intercept there. They're going to test 1.469, 3.598, and 4. And they all get inserted into your n of t equation. This is how you're going to find your n of n value to look for your max and mins. So n of 1.469, the bounds are the same, so that's 0. N of 3.598 is 71, n of 4 is 62. So between these two, your maximum value is 71. In this case, n of t is in terms of cars, so 71 cars. Any questions with these steps? Okay, can we go to number 6, page 14? And let's do a infinite series one. Page 14, this is number 6 on the 2022 FRQ. Part A, you start off with the ratio test. Find your potential interval of convergence. Test your endpoints to decide whether you're going to keep them or to include or not include them. Okay, any questions with part A? I should give you guys a little bit more time here before I jump to part B. So here's part B. Show that the absolute value of f of 1/2 minus 1/2 is less than 1/10. So anytime we see this notation, hopefully we're kind of understanding, okay, there's going to be some sort of error bound, right? We have to decide, okay, is it the Lagrange or is it alternating series error bound? And we look at our series here. This is alternating series that converges. So we know we might be talking about AST, which is the strategy there is looking for the first unused term to determine what the error bound is. So you may be looking at this and thinking, okay, I know f of 1/2 is if I plug 1/2 into the infinite series, and it gives me some exact value. Well, what does this 1/2 have to do with it? So if we were to test this out here and plug in 1/2 into the function, it'll be 1/2 minus 1/2 cubed over 3 plus 1/2 to the 5th over 5 minus 1/2 to the 7th over 7 plus dot dot dot. So this 1/2 is really just the first term, right? It's really just the first term. So basically, we're comparing the actual value with the first degree polynomial. So therefore, we know that the error bound for my first degree, for my first term, is going to be my first unused term, right? So I know that this x cubed over 3 is going to tell me about the accuracy of this 1/2 versus the actual value. So So therefore, we know the absolute value of f of 1/2 minus 1/2 is going to be guaranteed to be less than the absolute value of the third of the first unused term, which is the 1/2 cubed over 3. And if we were to clean this up, this ends up being 1/24th, and 1/24th is clearly less than 1/10. We've met our, we've confirmed that this is true, right? That our error bound is clearly less than 1/10 because our error bound is less than 124. Any questions with part B? And part C. Write the first four non-zero terms and their general term for the infinite series that represents f prime. So we go back to f of x, and we already see f of x spelled out for us. We just have to find the derivative. So we should do power rule for each of the terms. So you go to f of x and you start doing power rule. X becomes 1. You do power rule for each of the terms. You can also do power rule for your general term, right? Bring down the exponent and subtract 1 from that exponent. It cleans up to be just -1 to the x times x to the 2n as your general term. So this is my cleaned up f prime. All we're doing is we're just applying power rule from the f of x that they provide for us at the top of the page. Any questions with C? So part D says, use the results from part C to find f prime of 1/6. So basically, we want to find the sum of all of these terms added together. But we need to, if we look at this more closely, we can recognize, oh, this is just a geometric series, right? A geometric series with a ratio of negative x squared, right? And my sum for a geometric series is just a sub 1 over 1 minus r. My a sub 1 is my first term. My common ratio is the fact that it's negative x squared, right? I'm multiplying by negative x squared every time to get to my next term. So therefore, since my x is 1/6, my negative x squared is negative 1/36. So if I just recognize this as a geometric series with a common ratio that's less than 1, I know that I can get to my sum. So you leave your answer in this form, which is fine. This is non-calculator. So you don't have to clean this all the way up to 36 over 37. But as long as we're able to see that connection with geometric series and knowing that we can actually find the sum. Any questions? Yeah, we didn't have a lot of time, but I'm glad we got through 2 FRQs. So I wanted to share with you some additional AP exam resources. So we haven't used AP Classroom in this class, but that AP Classroom is available to you. So what I did was I released or I assigned more recent international multiple choice out to you. There are multiple choice tests in packet 6, but these are more recent years. So and I've released all the solutions too, so you can work through it if you'd like, if you just want some additional multiple choice practice. I mean, we have a ton of true response question practice. I'm not so worried about that, but if you feel like you need some additional multiple choice test practice, it's an AP Classroom assigned to your PC class. All right, come get your phones, and if you can also return the packet.
How did you get x squared on this? Like, how did that reduce to x squared?
So after all this cancels out, I'm just left with x cubed of x to the first power. Because this is the same thing.
Yeah, I had X cubed, so how'd you get X? Oh.
Guess that, yeah. Mhm.
Whoa, why? You also have your phone in my pocket as well.
I was in control of the.
Oh, no.
Okay, I encourage you guys to work through the 2022 FRQs if you have time today. And then tomorrow we'll pick out problems from 2021 FRQs.
Oh, yeah, I don't know why. I'm having two. You made it for guitar. So I swear to God, I didn't get it. Stop. Sure. Yeah. I got it in the mail. I got it in the mail.
Why? Nice. Still good for the education.
The only thing I don't tell